This is part 6 of section 6.4. We want to write the vector v in the form v1i plus v2j, given the magnitude of v and the angle theta that v makes with the positive x-axis. So here we were calculating the magnitude and the direction given the formula. Here we're given the magnitude and the angle, but asked to create the formula. Okay? And remember that our vector v is defined as the magnitude of v times cosine of that angle, I, plus sine of that angle, j. So given that, if I'm given the magnitude of v being 5 and our reference angle is 45 degrees, then my vector v is going to equal the magnitude times cosine of this times vector I plus sine of that angle times vector j. And we know these values. So I have 5 times square root 2 over 2i plus square root 2 over 2j. Now this is scalar multiplication times a vector, and we know that that distributes. And I end up with 5 times the square root of 2 over 2i plus 5 times the square root of 2 over 2j. Okay, so the same type of problem. Here our vector as magnitude is equal to 4, and our theta is 11 pi over 6, so we are in radians now. Remember, any measurement that does not include the degree symbol is assumed to be in radians. Also, you have the pi in there, which is usually a big clue. So my vector v is going to equal the magnitude, 4, times cosine of 11 pi over 6i plus sine of 11 pi over 6j. So I have 4 times cosine of 11 pi over 6 is square root 3 over 2i plus sine of 11 pi over 6 is negative 1/2 j. Now distribute this scalar over vector addition. The 2 and the 4 reduce so that you have 2 square root of 3i minus 4 times 1/2 will be 2j. Okay, so now after all of that, let's start talking about how these things can be used. Okay, we're now going to be moving into the world of physics. This is where these vectors have huge applications. If a system of forces acts on an object, the object will move as though it were being acted on by a single force, which is equal to the vector sum of the forces. Okay? This single force is called the resultant of the system of forces. So this type of thing is like, okay, you're flying due north, but the wind is blowing from the west. How does the wind push you? What direction do you really end up going? Okay? If the object doesn't move at all, the resultant is 0, and we say that whatever it is that's being acted upon, the particle, is at static equilibrium or just equilibrium. For an object to remain in equilibrium, the sum of all the forces must be the 0 vector. So basically, here we have a coordinate system that just mainly shows the first quadrant. Here we have the unit vector I on our x-axis, or j on the y-axis. Here's force 1, here's force 2, Here's the resultant if we added these together. And just imagine when we're adding, remember we're supposed to put the initial point of one of them at the terminal point of the other. If you imagine sliding this F2 up, you would get that right there, and your resultant is that. Okay? Now, in the real world, we're going to be dealing with a lot of things that require us talking about bearings. In navigation and surveying, directions are usually given by bearings, okay? A bearing is the measure of an acute angle from due north or due south, okay? The bearing north 40 degrees east means that we are 40 degrees to the east of due north. So due north, 40 degrees to the east of that would be right here, okay? South 30 degrees west is 30 degrees on the west side of due south, okay? So the first part tells you whether you're going to be measuring from the upper part of the y-axis or the lower part. So north, upper part, south, the lower part. And then this part, the E or the W, helps direct you to your quadrant. So N and E is the first quadrant, NW is the second, SW, third, SE, fourth. Okay? Now, one of the most important things here to notice is that a bearing measures from the y-axis, but in our formulas, our theta measures from the x-axis. This would be our theta on each of these. So we have to keep this in mind because when we're doing a lot of our calculations, we're going to need to know theta, which is the positive measurements from the x-axis, not the y. So we may have to do some conversions here. Okay, so let's find the magnitude and bearing of the resultant of two forces, F1 and F2, where F1 is a force of 25 pounds acting due south, and F2 is a force of 32 pounds acting due west. So the first thing I'm going to do is I'm going to draw a sketch so I get an idea of what I'm looking for. Okay. F1 is acting due south. So I have an initial point here, and F1 is acting due south. F2 is acting due west. So F2 is working in this direction. Okay? So if I imagine adding these together, so if I move this to the terminal point here, I'm going to end up over here somewhere. And this is going to be my resultant, which is in quadrant 3. So I need to keep that in mind. Okay? So the other thing we know is that the resultant is equal to the other two vectors added together. So this is equal to F1 plus F2. Okay, well, F1 is a force of 25 pounds and going due south, and that means that one has an angle of, well, this is going to be 25, so this is 0, negative 25. So it's going down 25, it's going down, so that's why I have the negative here. Okay, and then this one, F2, has a force of 32 pounds. And it's going on the west, which is in the negative direction. So this terminal point would be negative 32, 0. So F1 plus F2 would be these two things added together, which gives me negative 32, negative 25. Okay, now I want to find the magnitude of this. 32, not 30. So the magnitude of this will be the square root of negative 32 squared plus negative 25 squared, which is approximately 40.6. Okay, now to find the bearing, okay, the first thing I need to find is this theta. And then I can make adjustments by calculating. It's going to be south, some angle, west. But I need to find this first so I can figure out what that angle needs to be. All right, so to find this, this will be tangent of theta is equal to this over this, 25 over 32. Well, negative over negative is going to be 25 over 32 because the negatives will cancel out. And if you find inverse tangent of 25 over 32, you get approximately 38.0. Okay, this is in quadrant 1. I need to be in quadrant 3. So I'm going to add 180 to this so that it's in the correct formula of correct quadrant. And that gives me that the theta I'm looking for is approximately 218.0 degrees. Okay, so this gives me my theta, but I'm interested in my bearing. So right now, I have this measurement as 218.0 degrees, and I need to find this measurement. Well, this will be 270 degrees minus 218.0 degrees, which is approximately 52 degrees. We're asked around to the nearest tenth, and so this is exact. That's why there's a plus 0 here. Okay, so my answer for the bearing will be south 52.0 degrees, west.